Welcome back to this fourth tutorial in Introduction to R, and the last one we did was about vectors, and now we go to a little bit more complicated one, which is a matrix. So a matrix it's like a vector of vectors, so it's a collection of vectors, but vectors must have the same length and class between each other. And matrices is like taking numbers and making mathematical computation with vectors and operations, which we will almost never use except when we need a very fast coding, or we want to make a intensive modeling or something, and then we can pass to matrices and work with them, because sometimes they are much faster than the other things we can use in R. Okay, so let's make an example of it. So I have these two vectors here. One is 1, 2, 3, and the other is 21, 22, 23. So let's see them. 1, 2, 3, 21, 22, 23, and now I am calling this command, which is cbind, which it means column bind. So make two columns from these vectors, name them. The first column I want it to be named x, and it's equal to the vector x. The second column is gonna be called y, and it's equal to the vector y. So I'm applying that, and I can see here down in the console which is the result, and it's a matrix which has two columns, x and y, and has three rows: row number 1, row number 2, and row number 3. Okay. With matrices we can do a lot of operations. We can do, for example, m plus 1. This is adding 1 to each of one of the elements. But I also can do operations to matrix and vectors, like this operation here, that I am multiplying the matrix times the vector for 1. If I do that, I get another one, which is the product of those ones in taking rows, number 1, row number 2, row number 3. Okay? How do I access elements of a matrix? The access of the elements are using these brackets and then specifying the row and the column of it. Okay, so this is gonna access element number 1. This is access element number 3 in the first column. This next one is gonna access element number 2, so row number 2, column number 2, etc. We can make operations over functions, over matrices. We can transpose the matrix like this, or we can sum the elements of the matrix. We can also make the sum of the columns, so we will have two. Okay, so there is a lot of different. Let's check if we can do summary of m. I don't know if we can. Yes. So it's gonna make the summary of each one of the columns, the vectors that it contains. Okay, so we can do a lot of things with matrices. Here there is an example of trying to do dates, to put dates. So here you see I have as a date, x is as a date from 1 to 3, and origin is there. So if I show that, I have these days. Now I take also those ones, y, that are these days, 28, and now I'm gonna bind them together as we did before to make a class. But as you see, Now the dates are transformed into numbers because matrices don't get dates. So the class of M is going to be a matrix. The structure is like this one, and that's it. It's only to demonstrate that we must be careful when we bind together some elements. Sometimes we lose the information, as we lost now with dates, and take care that cbind is gonna give matrices. If we don't know what we are doing, it can be a problem. Okay, we are not gonna use a lot of matrices in epidemiology or in editing screening data or things like that, but it can be useful to know about them. Okay, so let's go to the next one, lists. Okay, so list is one of the main R abilities, subtleties, and things that we must really understand. So a list is a collection of anything, and a list has elements as a vector, but these elements can be dates, can be a vector, can be a number, can be a list, can be a data frame, can be a matrix. So list, it's the most container, the bigger container for anything in R. Okay, so here is how we build a list. So let us do this in real time, and like this we understand what we are doing. So first I define that X, I want to be a list. Okay, so I do that, a list. Now I'm gonna go and I do this to not to get confused. I say that the first element that I'm gonna call A, or say letter. This is the number, the name of the first element of the list, and I want to be a factor. And a factor of what? A factor of the letters from the first letter to the fifth letter, for example. Okay, so this is going to be my first element of the list. My second element, that I will call capitals, is going to be letters, so a vector from the 10th to the 20th. Okay, and let me do it like that because I don't like when it's. And now dates is gonna be equal to as date, so the date 2010 03, the 3rd of October 2010, and I will add to that a vector, so from that day to 7 days later. Okay, and numbers is gonna be from 100 to 93. Okay, so this is a list. As you see, X contains a lot of, let me erase that, a lot of information. So let's see the information of X. It's a list of 4 elements: letter, which is a factor with 5 levels, and these are the values; capitals, which it's a character vector which has 11, and these are the first values; dates, which is a date vector that has 8 values, and these are the values; and numbers, which is integers, which has 8 elements and goes from 100 to 93. Okay, so how do we access the elements of the list? If we want to access the first element of the list, which is, as we see here down, the first element of the list, it's a vector called letter, which is a factor which has 5 levels. So if we access that, it's with the two brackets. We need 2 brackets to access the element of the list. We also can access the element of the list by naming it. So in this case, the name was letter. So I can go and have the same. Okay. So we are accessing the element of the list, not the elements of the vector inside the list. So we are accessing this one. If I go to dates, I will have this one. Okay. I also can access the element of the list saying with this dollar sign and after the dates. One trick which we use so much is that we go here, we say dollar, and then we push the tab key here, and then when we push the tab we have the option of choosing which one of the elements of the list we have. So we want, for example, numbers, we type control and we can have access to that. If I look for another one, dollar, tab, key, capitals, and I have it. Okay, so this is a way to access the elements. Attributes of the list. So the length is 4 because we have only 4 elements. These are the attributes, which are the names only for the moment. I can change now the column names, or it's not the columns exactly, it's the element names. Element names. I can change the element names. Instead of letter, capitals, dates, and numbers, I can create that. And now, if I show that X, I have, these are all the elements. So C1, it's that vector, C2 is this one, C3, and C4. Okay? And this is the access to the elements. So then, if I say that, for example, this is the first part is gonna access the second element of the list, which is, we saw that it's this vector of letters, capital letters. And now once I have taken this, now I want to take only the second element of that vector. So I will have as a result key. So let's apply that. Because I selected only that, let me select that. Okay, and that's correct because it's the second element, the second part of the element. So if I take number 5, it's going to be n, etc. So I will always be able to access that. I can also do it like that. Dollar, I can C2, 5/5 element, n. Okay, so this is to access inside the elements of the list. Okay, operations over the elements of a list. So let's change the name, or let's copy the information of X into data. Like this, now we know that data, it's the data we are working with. So lapply data summary means that we are applying this function summary to the data, to each one of the elements of the data. So this means lapply. It's apply a function over each element of data and give the result as a list. So this is why there is this L at the beginning, because it means apply and return as a list. So if I do that, you will see here I have the result of it. It's that the result for the first element of the list is the summary is this, means that these are the levels and each one has one level. C2, the result of a summary means that length is 11, the class is character, the mode is character. Now this is saying the same for the dates, the minimum, the first quantile, and for the last one it's saying in the numbers which is. Okay, I can also apply data length, so then I know for each one of the elements of the list I know the length of it, 5, 11, 8 and 8. If I want, sometimes the result can be simplified if I change the function to supply, and then it's gonna try to make a vector from the result. So you see, much compact, the result of the length applied to data, but give me the result as a vector, simplified. So S means simplified. Supply is apply and simplify. And then I can see here very easy that C1, column 1, or element 1 is 5, element 2 is 11, etc. Okay, so then now it's gonna be more complicated, but it's the same thing. So I want to apply over data a function. We did before summary and length. So now it's a function I define. We will see in more detail functions. So I define a function that is taking if it's a numeric or if it's integer, take the minimum. If it's not, don't do anything. So take a non-assigned value. Give me a non-assigned value. So if it's numbers, give me the minimum of it. And if it's not numbers, give me non-assigned. So this is my function. So I'm going to apply that over the data. So this is the result. C1. So let me do it as a supply. And then the result is going to be compact and simplified. So you see, because the first element was a factor, it's not giving me anything, so it gets a non-assigned value. The second element was letters, was a string character, so nothing. The third element, that means, remember, it was a date, so it's not giving anything. And the last one, it's an integer, so it's in this condition and it's giving me the minimum of it. So this is a function that we did ourselves, and we apply that to each one of the elements of the list. Okay, we also can, well, let's see that for another time. I think it's enough for lists, because now we go to a special list which is called DataFrame. So DataFrame, it's a special list. Let's go to that. And DataFrames are one of the most important kind of data that we have, because we're gonna work with them all the time. DataFrames are the data collection with columns and rows, with different kind of columns. Like we can have factors, letters, dates, numbers, and a lot of operations that we're gonna do are gonna be over data frames. So each time we read data from CSV files or from other things, we put them in the data frame. Usually we calculate things over data frames. We keep the data in data frames, and so it's very important to understand them. But they are a special kind of list. So if you understand list, you will understand data frames, and vice versa also. So let's go to that. Data frames are the main class where we will have our data. They are lists with some special attributes where each element has the same length. Class is data frame, and we have row names that we can access to them. We have also names, as we have in lists, which are the names of the elements. So we can think about that each element of a data frame, it's a column, and we have rows and columns. So, but in reality, R is it's taking data frames as lists, and each element of the list, it's a vector. Every vector has the same length. Okay, so let's build one. So X, it's a data frame. It has the first element or column is called A, and it's a factor of 4 letters. B, it's letters, capital letters from the 21st to the 24th. C, it's some dates, and D, it's some integers. So let's apply that, and now let's see it. So you see now the result of it, it's much easier to read, not as before with the list, which we had every element splitted and it was difficult. Now we see the rows here, each row, and sorry, let's do it again. We have the columns names, we have the first row, second row, etc. Okay, let's see the attributes of X. So we have names, we have row names, and we have the class. So we can change the attributes with this command. Attribute of who, X, which one, row names, change it by for this one. So if you see now, we changed the row names. We also can change in this way the attribute name. If we do the same, and we do only names, and we put call one, okay, like this. So now call 1, call 3, and I forgot to put the name for call 4. Okay, so now I have this one. Okay, this is the same of doing this. Names of X equal or assigned to this. Okay, this is the same command. How do we access data frames? So same as for lists. So each column in a data frame is an element of the list of the data frame. So if we think as data frames as a list, each column of the data frame is the one element of that list. Okay, so we will apply the same thing as for list. So this is gonna give me, I change the names of the columns. So column 1 is this one. Remember that we can access that if we type the $sign and after tab key, we can access the column like that. Okay, I can access elements of columns in this way, because this first part is gonna give me the column, and now I access the element of the column there, because each element, each column of the data frame, it's a vector. So I am accessing the vector as a vector. Okay, I could say that X column 2, so Y is this one, and now I want to say that I want to access Y, the second element. Okay, this is equivalent to this command. Okay, Very important to understand that data frame is kind of a list. So how can we access the rows? The rows are easy to access. We are saying X the row number, and here we will put the columns that we want to have. If we don't put anything, then it will be all of them. So in this case, it's row number 1 and all the columns. So you can see here. Now, say that I want to take only the first, the third, and the second column in that order. So then I say indexes, I are like the variable indexes, I apply it to it. And now show me the first, the third, and the second, and all the rows and all the columns. And I can do that, okay? If I want to access, now let's see more detailed access the rows and the columns. So if I want to access all the rows and only column 1, I will put nothing here, comma, only the one I want to access. Yes, but this column was not there because I changed the name, so this is more correct. Okay? Row number 2 and all the columns, as we saw. Now, only call 3, only column 3, and the indexes that we defined before. So the result is a vector now, with only these 3 values. Okay? Now row number 2, column number 3. Row number 1, columns call 1 and column call 3, for example. Okay, so as you see, there is these several ways to access data frames, and we're going to use them all the time. So this is very basic, and you will see it again and again. Now let's go to how the difference when we access a data frame and the result is a vector or is a data frame. Sometimes it's important to know that. So when we do that, sorry, this is now it's changed the name, column 1. So now I want to access the column number 1, and which is the class of it? It's a factor, so that means that it's a vector that contains factors. Okay, but if I access this one like this, which is gonna be the same kind of data because the class of it is gonna be also a vector or factor. But now, if I access the first row and the first column, my class is gonna be also a vector. Okay? So when I take only one column, I am getting a vector. But now, if I take in this way, column 1, the result is a data frame. As you see, I have the row elements because I didn't specify any row. Okay? If I would do that, this would give a vector, because you remember that to access the elements of a list, I had to put 2 brackets. If I put only one, I get a data frame because I'm not getting inside the element. Okay, so this is something we have to take into account. If I do that now, of course, only one bracket, then I am taking the result as a data frame. This was call 3, call 2, for example, and that's a data frame. Okay, only that for you to know the difference. Sometimes it's useful. It's kind of an advanced thing, but okay. So now let's see how we can subset a data frame. So we are gonna use it a lot in all the addition process. So we take this command and we say, okay, so now our data frame is X, and I want when let me change the names to A, B, C, D, because so let me change before that the names A, B, C, D. I could have done these letters from 1 to 4, okay? But I didn't do it anyway. Okay, so now I can proceed with what I have done before. So Y, it's a subset of X, where D, the column D, is bigger than 112, and A is different of D, of the character D. Okay, so this is the subset. Okay, I get this data frame. Same thing would be to first look which are the indexes. So which are the rows that have this condition true. So I say which xd, xa have these conditions. You see, I have to access the vector and I have to access here. Okay, so then this is only number 3 and I get the same result. Other way to do it is to take, now let me show the result. Now with means that with x, so going kind of my data is gonna be x. So with my data, do that. So I don't have to specify here x dollar anything, because I said with x, with x. So when I say that, I can put the column names without having to put this kind of x and that. So this is very useful. This is gonna give me a Boolean vector of true and false. You see, false, false, true, false. But I can subset, as I did for vectors, I can subset now with this vector and get the same result as before. Okay? So this is 3 different ways to subset a data frame by a condition or function or anything. It's very important, and we will use these 3 ways in very intensively when we are editing data. Adding columns. So I can add a column like that. So I say, now take me a new column which is called E, and now it's a vector of numbers that contains from 345 to 342. It must be as the same length as the other ones. So if I do that and now show it to me, I have there my new column. Okay. If I want to take only some columns and not all of them, if I do that, for example, x minus 1 is going to take out the first column. You see, in the result, I don't have my first column A here. If I would have to do that, don't take neither the first, neither the third. Okay, I have that. Now take only C and D, A and D, sorry, columns A and D. Now I can use imagine that I want to take out only column number C, for example, but I don't want to write take A, B, D. Only say to R that it takes out number C, also the one which is called C. So I can use this function which is called setDiff. So that means which is the difference in these 2 sets. So the difference in the names of x, remember that names of x, it's this vector A, B, C, D, E. So which is the difference between these 2 sets? the sets of A, B, C, D, E and the set of C. So it's gonna be, the difference is A, B, D, E. So it's the ones which are here but are not here. Okay, so then I can subset now my, and this is like taking out column C. This is important because sometimes our data contains a lot of columns and they are named very different, and it's really tedious to make like X over C. The first name is region, and after second name is ID, the third is diagnose, the fourth is treatment. So we had to do that all the time, and we can so quickly erase a few columns saying this command, and it's safer because we are not gonna make mistakes. Okay, so now applying over the columns is the same, this is the same as applying functions over elements of a list, because each column in a data frame is an element of a list. So we can apply the same, like class, apply over the columns, class. Now we can apply for each column, give me only the numbers of it and give me a vector. Simplify me that thing. If you simplify me that thing, it's gonna give a matrix because the vectors are the same class, and then it's gonna give a matrix. So you have to be careful with what you get when you apply things. Another, sometimes you can apply functions over all the data frame, like as summary, for example. Summary is applying directly into each one of them and making a summary of each column. Say now that we want to apply and get the result as a list over X, a function that we say it's the range. Range means which is the minimum and which is the maximum. But we take the range of the columns in this case, because this is going to be applied over the columns when we take them as an integer, as numbers. And then take all these results, which is a list, and convert it into a data frame. So this complicated function is gonna give that. Okay, is the range of the values as numbers. If we do that, this is applying as an integer, we get this matrix. So I can convert that as data frame. Okay, so now I have a real data frame. Now I can apply, this is a new function, it's not supply, it's not lapply, apply over the data, and this is where one means that I apply it over the rows only, and I apply this function. Okay, so for each row I make the sum of all of the values and I get that. So I had 4 rows and now I have 4 results. If I apply it over number 2, 2 means the columns. This is like the margins, it's called. Margin 1 is rows, margin 2 is columns, the sum. So now I'm applying the sum over the columns and I get this result. Okay. How to append rows to an existing data frame. So now let's choose only one row. So row 1. Let's see it. So this is row number 1. I want to change something like the value of this one. So let's show it again. No, so now I have here, instead of having A that I had before, I have Z. Okay. So now row 1, it's a let me change now row 1 column E, and I'm gonna make it to be this number. So let's see it again. So now I have this number here. So now I want to add this row to my data to put it at the end of it. So I'm gonna use array bind, row bind. So that means that from this data add me this one. Okay, so then, and I have now another row, the extra one, which contains that. Let's go to structure to see my data frame. How is it? So now it has 5 observations of 5 variables. My factors now, before they had 4 levels, A, B, C, D, but now they have 5 levels, A, B, C, D, Z, that we don't see here. Nothing changed in the factors, the dates are like that, the integers, and these are the values. Okay, so observe that there is a new level on the column A, that ArrayBind automatically added a new level in the factor, accounting for the new value of Z. Okay, so this is the end of this long tutorial about lists, data frames, and matrices. And it's also very important, but we will see again and again this kind of data, mostly data frames, and we will learn by doing more about the access, the subsetting, and etc. Okay, see you next time.